Hi, welcome back to GSC Go Science Crazy. My name is Jacob, and today we're going to be talking about the Van de Graaff generator. This famous gadget, which you might recognize from movies and TV, is perfect for teaching electrostatics, and when we're done learning about how it works, we're going to use it to perform some shocking experiments.
But first, before we get to those experiments, let's talk about how your Van de Graaff generator is constructed and which electrical principles make it shoot off sparks and change the charge of any objects touching its dome. In basic terms, it works by spinning a rubber belt between two plastic rollers with the help of an electrical motor. Let's open it up and take a look inside. You can access the top half of your generator by simply lifting off the top of the metal dome. You will see a plastic roller, a rubber belt, a metal comb to collect electrically charged ions, and a conductive metal mount for the roller and comb, which is in contact with the inner surface of the metal dome. Between the top and the bottom of the machine, the belt spins in a sealed plastic tube, preventing it from picking up any dust or dirt in the air that would prevent it from working effectively. To see what's going on the inside of the bottom half of the generator, you're going to need to use a small Phillips head screwdriver to remove each of the 4 screws holding the base in place. Removing the bottom won't generally be necessary for you to successfully use your machine. That said, it can be useful if you ever need to clean or replace your belt. With the plate removed, you'll see an electrical motor attached to a setup similar to the one you saw up top, a plastic roller, the rubber belt, and a metal comb to help produce charged ions. The motor only spins the bottom roller. It provides no electricity to the machine. You'll also see the light bulb used to illuminate the tube that houses the belt, as well as the grounding wire attached to the comb that prevents charges that are unwanted from building up. Before we get started using our generator, let's explain some basic concepts. Most importantly, you'll need to understand the concept of static electricity. Unlike current electricity, which occurs when electricity flows through a wire or some other conductor, static electricity occurs when an object develops a positive or negative electrical charge on its surface from an imbalance of electrical charges. All objects, or more specifically the atoms that compose them, are made up of neutrons, protons, and electrons. Positively charged protons are bonded to the neutrons in the atom's nucleus, while the negatively charged electrons float around it. Neutrally charged atoms have an equal number of electrons and protons. However, electrons can be gained or lost from an atom. Negatively charged atoms have gained electrons, while positively charged atoms have lost them. Objects can gain or lose electrons in multiple ways, but the primary processes behind the static electricity in your generator are known as the Triboelectric effect and electrostatic induction. The Triboelectric effect refers to the exchanging of electrons when objects come into contact with each other and are pulled apart. Certain materials are more likely to lose electrons, while others have more of a tendency to pick up loose electrons. When objects with differing triboelectric tendencies come into contact with each other and are pulled apart, the object that lost some of its electrons now has a positive charge, and the object that gained those electrons now has a negative charge. The last major concept to understand is electrostatic induction. This concept basically states that a neutrally charged object placed near an electrically charged one can gain a charged region opposite of the nearby charged object. A negatively charged object placed near a neutral one will induce a positively charged region by repelling that object's electrons away. The opposite occurs with a positively charged object. Now it's time to look at how your generator makes use of these concepts to generate thousands of volts of electricity. The process for generating electricity starts with spinning the bottom roller using the motor. When the roller spins, it moves the belt, and the triboelectric effect causes the roller and the belt to each gain a charge. Charges tend to spread out evenly and stay put on smooth surfaces, building up until they discharge or dissipate. Sharp points or edges, however, provide great points for charges to leave an object. Because the sharp edge of the comb is what's pointing towards the roller, the charge induced on it wants to discharge towards the roller, but it is blocked by the belt and the air between them. The charge in the comb builds until it is strong enough for the air to go through what's known as electrical breakdown. When this happens, instead of insulating and preventing the flow of electricity, the air becomes a conductive plasma in a process called corona discharge. The ions in the plasma of the corona discharge share the same charge as the one induced on the comb, and are therefore attracted towards the roller. Instead of collecting on the roller, however, the belt blocks the way and these ions stick to it. As the belt rotates, these ions are transported towards the roller and the comb at the top of the generator. The comb in this step is connected to the ground so that no unwanted electrical charge builds up in the machine. Next, the now charged belt moves up to the top and induces a charge on the comb up there. This comb is connected to the inner surface of the large metal globe, and its induced charge is carried by conduction across its entire inner surface. Depending on the design of the generator, This top roller must be triboelectrically neutral or opposite of the bottom roller for this machine to work. An oppositely charged roller will result in a generator capable of producing much higher voltages. And lastly, the charge on the inner surface of the dome induces an opposite charge on the outer surface. This electrical charge will continue to build and build on the surface of the globe until it discharges in the form of a dramatic spark when something comes nearby. If nothing comes close enough for the static to discharge as a spark, the charge will continue to grow until it leaks off into the air via corona discharge. The amount of charge that could build up on the globe in any given day is dependent on the relative humidity in the room and the cleanliness of the globe. A drier day will allow for greater voltage to build up on the generator before it discharges. Before we get started using your generator, let's go over a couple more tips about how to use it safely. The shocks from your generator can be slightly painful, but they're not generally harmful. If you have a heart condition or a pacemaker, however, it is best to stay back several feet and let someone else operate the machine. For the safety of any of your electrical devices, remove any watches or headphones you may be wearing when you're using the generator. Also, remove any loose jewelry that could possibly attract charges. Finally, if your sparks are underwhelming, this could be due to either high humidity or dust buildup. Cleaning the inside and the outside of your globe and the belt can help improve its performance. Now, it's finally time to look at some of the cool demonstrations you can do with your generator. If you've ever seen a Van de Graaff generator before, this first demonstration is probably one of the most recognizable ways you've seen it used, aside from using it to make simple sparks. By placing our hands onto the globe of the machine and making sure that our feet are not grounded, we are going to use it to charge our hair so that each piece stands on its end. After setting up your machine for use, place a stool or a chair near the table your generator is on and stand on it. Make sure that it isn't metal. Now, no current can flow from you into the ground. Now, place your hands on the globe of the generator and turn it on. It can help to have a partner to flip the switch on for you. Shake your head around a little as the machine runs. Slowly, the same charge on the globe's surface will begin to build up on your body because you are not grounded. As each individual hair on your body becomes similarly charged, they begin to repel each other and stand on end. You can watch this happen to my hair over time over about a little more than a minute. That said, this demonstration could be more impressive to look at with shorter hair that doesn't weigh quite as much as mine does. When you're all done, it helps to have a partner turn off the generator before removing your hands. You may notice that you stay charged as your hair stays standing up until you step off of the stool. The next two demonstrations also involve using the generator to pass its charge onto something else and then getting that object to move. The first of those demonstrations will be with charged muffin liners or pie tins. To do this, simply stack at least 5 muffin liners or pie tins on top of the generator's dome with the open side down, and then turn the machine on. Watch as the liners fly off one by one. This is because they pick up a charge and repel each other, much like your hair did earlier. Some might even stick to the wall as they retain their charge. Don't be discouraged if it takes a couple of tries to get this to look good. A lot of factors can affect how well your particular liners work for this experiment. Expect a few duds. The last of these kind of demonstrations is done using a cotton ball tied to a string. First, set up your generator so that sparks are flying between its dome and the grounding wand. Then, tie a cotton ball onto the end of a string and lower the ball into the path of the sparks. Watch as it bounces back and forth between the two. This is because the neutral cotton ball is attracted to the dome until the moment it makes contact. Once they touch, the ball becomes charged and it is repelled away. When the ball bounces back into the grounding wand, it becomes neutral again and the process repeats. These last two demonstrations relate back to what we said earlier about charges sticking to smooth surfaces and being attracted to sharp points. We are going to be using a metal needle for them. First, we're going to be simulating a lightning rod by pretending as if you are a skyscraper and the generator is a cloud in a storm. Like before, set up your generator so that sparks are flying between it and its grounding wand. Grab a needle in your hand. Make sure that your skin is in full contact with the metal on it and that you're standing on the floor. With the machine turned on and sparks flying, point the tip of the needle towards the dome of the generator and watch as the sparks stop. This is essentially performing the same task of a lightning rod. The sharp point of the pin and its connection to you as a grounding point make it a better path for electricity to travel to the ground rather than through high voltage sparks. The charge on the dome bleeds into the ground through you and the lightning rod before it is allowed to build up enough to cause a spark. And finally, we're going to be observing what's known as electric wind and see corona discharge firsthand. With your machine turned off, Use some tape or any form of tacky putty to fasten your lightning rod needle to the surface of your dome. Set it up so that your needle faces perpendicularly to the surface. This experiment benefits with the lights turned off so that you can better see the corona discharge. With the needle in place and the lights turned off, turn the machine on. Wave your hand in front of the tip of the needle to feel the wind coming off of it. This is caused by the charge from the ions in the plasma of the corona discharge coming off of the tip of the pin and disrupting nearby neutral air molecules. If you look closely with the lights turned off, you can even see the pale blue light coming off of the corona discharge. And that's it for today. If you're interested in more cool science projects and experiments, visit us at www.gosciencecrazy.com. Goodbye!